Okay, so this third activity in here, just being able to graph with various bases without too much of a struggle, right? And see how it's related to the graph of the exponential function. If you're graphing y equals log base 2 of x, again, I started you with a table over here. If you kind of finish that table, when you're thinking of the logarithm of a number, you're thinking of what power of that base is it. So you want to pick things here that are nice powers of 2. So you already started with some. The ones maybe that are harder is this log base 2 of 1, 0, right? The log base anything of 1 is going to be 0 because that's what power it is. That's the power of any base you put here. That's what power 1 is, right? 2 to the anything gives you... not 2 to the anything. 2 to the 0. This is going to always be 0. This is going to be negative 1, negative 2, right? A half, a quarter, an eighth. If you graph those things, it's always going to, the logarithm graph's always going to pass through there for the same reason that the exponential graph always passes through here. Exponential graph, like 2 to the x looks like this, and it has a horizontal asymptote. The logarithm graph looks exactly opposite. These points are all reflected here. 2 is 1, 4 is 2, right, this point right here. 3 is 8, 4 is 16. The next one you wouldn't be able to get on here, I don't think, because 32 is off the grid. So if you're trying to draw this, I noticed a lot of you started here and did a nice beautiful curve for this, except you maybe didn't do what I just did. Started going all, and now realize it's not going to go up like that, right? I should have let go before I did that. Can't erase part of it. It's not gonna reach the next number until 32. So out there somewhere. The other thing is this part of it. It exists down there. I know maybe you're afraid to do some negative ones, but you do have negative logarithms. You just don't have negative numbers that you can take the logarithm of. X can't be negative here. You're not going to have anything on this side for a logarithm graph. For the same reason, you're not going to have anything down here for an exponential graph. You can only choose numbers for x here that are greater than 0. It's never going to reach 0. It's going to continue to go down here, right? A half is negative 1, a half negative 1, a quarter negative 2, an eighth negative 3. This is going to follow this line here. It's going to get closer and closer for the same reason that this line for an exponential function followed that way. A logarithm graph has a vertical asymptote. Okay, vertical asymptote. The asymptote is x equals 0. When you graph the other ones here, y equals 10, log base 10 of x is harder. It's going to pass through that one, the same as this one, right? 1 is 10. But if we're filling in some kind of a table, let's just make a new table down here because it's not going to be that big. X, y. If we're doing log x, log base 10 of x, log of 10 is 1. Log of 100 would be 2. That's way off the grid. No point in going any further than that. Log of 1 would be, what is it? Same as it always is for any base. 0, right? What would be a point I could put here? How would I get negative 1? Keep dividing by 10 here, right? 1/10 or 0.1. That's probably enough to get the shape. It's going to be 1/10 negative 1 over there, and it's going to be all the way up to 10 here, which is right here. There's 10, there's 1. The next one would be 100. It would be way over here before it even gets up to 2. So this one is really close to the axis really quickly, and it turns really sharply before getting to here, and doesn't even get up. I even drew it going up too quickly there. The turn is sharper the bigger the base. Just like the turn was sharper over here. When you had 10 to the x, it went up really quickly here. Sharp turn. It's just a mirror image of itself in that line. Okay. For y equals b to the x, it curves up more sharply. For y equals log base b of x, it turns sideways more sharply. Okay? as a kind of a summary here, I'm going to skip ahead a bit because I think I have a feeling I put a space in here to do some kind of a summary of logarithm graphs. Well, what do you know? I didn't. Why don't we add one somewhere? You can find some space somewhere. This could potentially be for logarithm graphs here. Just a sort of summary for yourself for exponential and logarithm graphs. Okay, this is going to be the graph of y equals b to the power of x. This is the graph of y equals log base b of x. X log. Okay? Split it apart there. I don't know, just find some blank space somewhere, I guess. Exponential functions, remember, pass through here. This is 1. This was if b was what was true about b. It went up to the right like that. What had to be true about b to get it to go up to the right like that for exponential graphs? The base is what? Not positive. Bigger than 1, yeah. It's going to go down to the right here, like this. It's going to be its mirror image. It's going to go down to the right if what's true. Try again. Whoa. What happens here? What has to be true of the base to have this happen?
It is Monday morning. Here are your announcements.